All right, 8th graders, this video is to help you with some of the problems on CR 32. I believe Ms. Pearson got lots of these questions from released high school Regents exams, so this will tell you that this is how questions will be asked next year and beyond. So let's go ahead and take a look at number 1. In 2013, the Los Angeles Dodgers opening day payroll was about 2.6 times 10 to the 8th dollars, and the Houston Astros opening day payroll was 2.4 times 10 to the 7th dollars. How much higher was the Dodgers payroll? Okay, first of all, we normally don't give money in terms of scientific notation, but I'm guessing it's because these numbers are so huge that the Dodgers have to pay out and the Astros have to pay out. Easier to write in scientific notation. So if you want to know how much higher the Dodgers payroll was. So you know the Dodgers payroll was higher. We can see that the exponent here is higher than that one. What you're going to do is just subtract to figure out how much higher. So what we want to do is we want to take the Dodgers payroll, 2.16 times 10 to the 8th, and subtract off the Houston Astros payroll, 2.4 times 10 to the 7th. So if we're subtracting in scientific notation, our exponents have to agree. And so you have to do your LA notebook or your friend Lars. And I believe the teachers tell you to always go to the higher exponent. It's just easier. So we're going to take this 7 and make it an 8. So we're going to do Lars, or LA, left add. That stands for left. If you move that decimal point to the left, you're going to add 1 to the exponent here. So I'm going to go ahead and move this decimal point 1 to the left, which means I'm going to add 1 to that exponent. So let's just write the way the number should look, because you never want to have 2 decimal points in a number. So this is 216 times 10 to the 8th minus 0.24 now times 10 to the 8th. Now our exponents agree and we can go ahead and subtract. If we're subtracting, the times 10 to the 8th will remain the same. And then we'll just subtract these first factors. 6 minus 4 is 2. You can't take 2 from 1. Borrow 2 becomes a 1. This becomes an 11. 11 minus 2 is 9. Keep my decimal point, and we have 1. So 1.92 times 10 to the 8th dollars. If you want to write that out in standard form, it would be 1.92, and we'd move our decimal point 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, filling in 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3. 1, 2, 3. So in standard form, the Dodgers payroll was 192,000,000. So that would be $192 million higher. So they had to pay their players an extra $192 million. That's a lot of cash, which is probably why they put it in the in scientific notation. And that's just the difference between the two. Holy shamoly, baseball players get paid a lot of money. All right, let's go ahead and look at number 2 together. Hopefully that helped on number 1. Let's take a look at number 2. Another disclaimer, like let's say I make a little calculation error. You better be double checking me. All right, so here we go. Let's take a look at number 2. It says describe a sequence of transformations in detail to show that parallelogram ABCD is similar to parallelogram A prime, B prime, C prime, D prime. Okay, so if I want to describe a sequence of transformations to show that 2 parallelograms are similar, I'll have to have some sort of dilation happening for them to be similar. Otherwise, if we just had rigid motions, translation, reflection, rotation, those figures would actually be congruent. But we can see that this parallelogram is definitely larger than this one. Now here's the dealio, and Miss Pearson might not agree with this. She might want to She probably wants you to go from A, B, C, D to the prime. I'll do what she wants to do. I think it would be easier to take this one, to rotate it up, and then expand it. I'm thinking about doing it backwards. She'll be so mad at me. But we just want to show they're similar. I'm actually going to start with the image. I'm going to take A prime, B prime, C prime, D prime, and I'm going to take this image and I'm going to rotate it back up to lie right on top of this parallelogram. So I'm actually going to map this image back onto the original. So let's go ahead and take a look. And the reason I'm going to do that, I can automatically see that this point C is staying the same. That vertex is going to stay the same. So I can see that I'm just taking this parallelogram and I need to sweep it back up on top of this one. And if I take a look at this, if I do, this is, you can see moving in A. If I'm rotating it around, this is going to move up in a clockwise rotation. So what I would do is, step one, I'm going to map the image back onto the original. You can do it the other way, but I'm going to choose to map the image back onto the original. So I'm going to go ahead and rotate A prime, B prime, C prime, D prime, 90 degrees, and I'm sweeping it up this way, and that would be the direction of a clock. You think about when you have a clock going, the hand of a clock goes around this way, so it's 90 degrees clockwise, 90 degrees clockwise, and it's about point C. They want us to get real specific. So we're going to rotate this one 90 degrees clockwise about point C. You can see that this hinges and it doesn't move, so I'm going to go ahead and sweep that up. So if I do that, if I rotate this 90 degrees clockwise about C, D is going to land up here. So what I'm going to look at here, it's a rigid motion, so I know my side lengths will stay the same. So C is going to stay right where it is, and then 1, 2, 3 away has to be D. So 1, 2, 3 away has to be, I'm going to call this for fun right now, I'm just going to call it D double prime. So I have to sweep that up, but the side length, 1, 2, 3 units, has to remain the same, 1, 2, 3 units. And at that point, I should then hopefully be able to figure out where the B and the A go. So if I have this, I can see I cut through a box to get over to the A. So I believe my A should be about here. I believe this should be, I'm going to call it A double prime. And then to get to B, from A to B, it's 1, 2, 3 units. 1, 2, 3 units. And then I can see, so this would be like my B double prime. And I can see right here, it cuts through a box to get back there. So hopefully I've drawn this image nicely. So I first did a rigid motion, and I went ahead and I took my original, or not my original, I took my image and I swept it up. So now I have this parallelogram lying inside the larger parallelogram. So now I'm getting ready to blow it up. Now that I have this one, I've rotated, I'm going to go ahead and blow it up. So the second thing I'm going to do is I'm going to dilate. And this time I drew this in. It's going to be A double prime, B double prime. This is C. I could call it C double prime if I want. And D double prime. C really all stays the same. So I guess we don't even have to put primes on any of our C's. Because really, C is the one point that's going to stay the same the whole time. Because I'm now going to do my dilation about point C. So I'm going to dilate this with center of dilation at C. Now I have to just figure out how much am I blowing it up. Well, the reason I mapped this one onto here, because it's going to be pretty easy to see how much you have to blow up this parallelogram to make it match the larger. So if I look here and I know this is 1, 2, 3 units from C to D double prime, well, how many units from C to D? It's 1, 2, 3, 4, 5, 6. So I'm just doubling this length. That gives me my scale factor. I'm just going to go ahead and double this length. So with a scale factor of, how do you get from 3 units to 1, 2, 3, 4, 5, 6 units? Oh, so I'm going to dilate this parallelogram right here at C with a scale factor of 2. Okay? Because 3 times 2 would get me the 6 units across. So let's just double check. See how this, if I go from C and I'm dilating this one, see how I cut through one box? Well, then to go from C all the way to B, I cut through 2 boxes, because 1 times a scale factor of 2, this new length would be 2. Same with A. If you draw a ray from C through A double prime and continue that ray off, it's going to land right on the A. So hopefully you can see that this parallelogram right here, I'm just going to blow up by a scale factor of 2 to get the larger parallelogram. And so then this, I believe, would be fine for your describing in detail. Now we have to say why it's similar. A prime, B prime, C, D prime is similar. My spelling is terrible. Similar to A, B, C, D, because it is produced using a rotation, which is a rigid motion, which would cause them to be congruent, and a dilation. And a dilation is what causes them to actually just be similar. The angles will all stay the same size. The sides will be corresponding sides will be in proportion, but it's a larger version. So they're similar because it is produced using a rotation and a dilation. Dilation causes the parallel, I'm not explaining this, like parallelograms to be similar. Your teacher might want you to go in detail and say, once we have a dilation, we know the angles will be the same size. So the angles, corresponding angles will have the same measure. Corresponding sides will be in proportion. They might want those keywords. Corresponding angles have the same measure. Corresponding sides are in proportion. Hopefully something along those lines would get you full credit on this. This was not an easy problem. And you could also have taken A, B, C, D. You could have shrunk it down by a scale factor of 1/2 to get this smaller parallelogram. Then you would have had to rotate it 90 degrees counterclockwise to land here. So if you had started with the larger, your write-up would be something to the effect of, you dilate the A, B, C, D by a scale factor of 1/2 to get this smaller one. Then you would end up rotating it 90 degrees counterclockwise to land here. And I guarantee you that's really what Ms. Pearson was looking for, but I'm pretty sure if I start with the image and go back to the original, they don't tell me what I have to do. They just have to say that they're similar. So I mapped the image back onto the original. All right, I'm going to make a different video for the next several because this was a little long-winded. Sorry about that. Hopefully it helps though.